All right, boys and girls, today we're taking a break from factors and divisibility, and we're going to have a lesson on fractions. Now, eventually, you'll get very comfortable with your fractions. You may already be so. And you'll be able to do much of this in your head. In today's lesson, we're going to just take a little baby step in fractions, and we're going to look at how we can use pictures of fractions in order to compare their sizes. In other words, which fraction is bigger or smaller than another fraction. First of all, let's again review just a little bit of our terms. I think in an earlier lesson I used the word simple fraction to refer to our most basic fractions. The more accurate term is really a common fraction. In a common fraction, we have our numerator on top, our denominator on the bottom. The numerator tells us how many parts, and the denominator tells us how many total parts there are. If we look at the drawings at the bottom of page 100, we see several fractions drawn out and illustrated using pictures. We typically use circles to illustrate fractions, or perhaps a rectangle shape. One of the key things to notice anytime we are drawing fractions and comparing fractions is that, first of all, when we draw an individual fraction, for example 1/2, our two chunks or segments must be equal. In this case, the line dividing this circle into two parts divides it exactly into two equal parts. Again, the line for dividing this rectangle into two sections divides it into two equal sections. You'll notice the same as when we divide into 3 equal parts, 4 equal parts, 5 equal parts, 6, and 8 equal parts. The next thing that you want to be very careful of is that when we begin comparing fractions using pictures, is that our shapes are the same and that they are equal in size. In other words, if we're asked to compare 1/2 to 1/3, notice that I'm going to compare circle picture with a circle picture, and that my two circles are the same size. Within each picture then, 1/2 is divided into equal sections and the thirds are divided into equal sections. If we make sure those things are in place, we can see by looking at our shaded areas that 1/2 is greater than 1/3. Let's turn the page and look at a few examples together. I will probably go through this fairly quickly. We are asked to draw pictures to illustrate that 1/4 is less than 1/3. So, first of all, decide if you want to do circle pictures or rectangle pictures, and draw either 2 equal circles or 2 equal rectangles. I'm going to just draw a rectangle example off to the side. Now, take your first shape and divide it equally into parts according to the denominator. So here I need 4 equal parts. On the second fraction, I need 3 equal parts. Then I shade my fractional part, and I see that 1/4 is less than 1/3. In example 2, we're asked to draw and shade rectangles to illustrate this comparison, 3/4 and 3/5. I'm going to do this on a larger piece of paper. How does 3/4 compare to 3/5? We are asked to use rectangles. Begin by drawing, to the best of your ability, 2 equal rectangles This is the sort of problem, especially when you're drawing rectangles, it might help you to go and get a piece of graph paper and solve on that, because you can use the lines on the graph paper to make sure your sections are equal. In the case of the first fraction, we are showing 3/4. We begin by looking at the denominator. 4 indicates how many total parts. We need to split this shape into 4 equal parts, and then we will color 3 of them. In the case of this fraction, looking at the denominator, we have 5. We need to split this shape into 5 equal parts and then color 3 of them. I now can compare the shaded areas, rectangles, and I see that 3/4 is greater than 3/5. Let's check our work. There we have similar pictures. And yes, 3/4 is greater than 3/5. Would you go ahead, please, and do all of your lesson practice? Notice that in A and B you will do circles, and in C and D you will use rectangles.